Hi everyone. So today we are going to solve a lead code medium problem. Count number of bad pairs. The problem states that we are given an array nums of integers, and a definition of a bad pair is like the values at indices I and j. So if j minus I should not be equals to nums of j minus nums of I. So the difference of indices should not be equal to the difference of values. Now, for all the possible pairs in the given array of integers, we need to return the total number of bad pairs. Means the pairs which satisfy this given condition. So, for example, in this given input, so if we consider index 0 and 1, so this is a bad pair because difference of 1 minus 0 is not equals to difference of 1 minus 4, the values. Similarly, if we consider 0, index 0 and index 2, so 2 minus 0 is not equals to values 3 minus 4. So hence, this is also a bad pair, and so on. So the total number of bad pairs for this input is 5. So the brute force way to go for this problem would be to try for all possible pairs. So uh, all possible pairs, try. So for example, we'll run a loop for I from 0 to n minus 1, and j from I plus 1 to n minus 1, because j is greater than I. And then we'll check if j minus I is not equals to uh, nums of j minus nums of I. And if this condition is satisfied, then we will increase our result by 1. Result plus equals to 1. So but since our constraints are of the order of 1e5, so this n square approach will be of the order of 1e10, which will not be acceptable and will give us state. So let's see the brute force code here. So uh, we'll just maintain a global variable result and just traverse through all possible pairs and see if the given condition is satisfied. Nums of I minus I is not equals to nums of j minus j. Then we will update our result and finally return the result. So this will obviously give us daily. So we need to optimize or do some pre-computations so that if we are at a given index I, for example, uh, we are at a given array. So suppose we are at a given index I, we must be means it should be possible to find out the number of bad pairs on the left or the number of bad pairs on the right in constant time or log n time. Both are acceptable. So we need to devise some algorithm such that for each index, means you'll need to traverse through each index at least once, and for a particular index we should be able to find out the number of bad pairs on its left or on its right. So if we are traversing from the start only, so if we are somehow able to find out the number of bad pairs on the left, then we will just keep increasing I and continuously means adding the solution for number of bad pairs on its left, and that will give us the solution for overall means all possible ends. So what I'm trying to say is, for example, we need to find out number of bad pairs ending at I for all I greater than equals to 0, less than equals to n minus 1. So if we do this for each I from 0 to n minus 1, then for example, if we are here, then all the bad pairs will be accounted. Then I moves here. Then all the bad pairs from here to here will accounted. Then I moves here. Then all the bad pairs from here to here. And similarly, we'll able to calculate the overall result. Now, how do we find out the number of bad pairs ending at I? Means the right value is I. Means nums of I. So generally in these kind of problems, we try to rearrange the given formulae and means try to means modify the given array so that we only need to handle means deal with a single index only. So for example, here we are given that j minus I should not be equals to nums of j minus nums of I. So here we can see that here j, we are taking difference of j with I and then taking difference of nums of j with nums of I. So what if we take difference of j means put together j and nums of j and put together nums of I and I, so that if we are at a given index we'll be able to calculate the required values. So this is what we generally try to means do in these kind of problems. We modify the formula such that we only need to means deal with a single index. So here if we rearrange, we'll get nums of I minus I is not equals to nums of j minus j. Now if we create a new vector, for example update this nums of I vector with nums of I minus I equals to vec of I. That means we created a new vector whose values denotes vec of I equals to nums of I minus I. So the new formula would be vec of I is not equals to vec of j. So as we can see, we if we modify the given array with nums of I minus I, then we just need to find out the number of pairs which satisfy this condition. So now what we'll need to do is at each index in the modified array, we'll just need to find out the number of values which are not equal to vec of I, right? And we can do this for each index from 0 to n minus 1. So we see that we means reduce this complex formula into a very simple form. Now we just need to find out the number of values on left which are not the same as the current index, and we'll just update the result. So this is what we generally need to do in these kind of problems. So for every new element in index I, we look at all previous elements and calculate how many of them form a bad pair with I. So and how, those pairs will be vec of j which is not equals to vec of I, right? So hence we just need to find values other than vec of I on left, right? So this is what we do, and the number of like bad pairs ending at I would be the total number of previous elements. So previous elements would be 0 to I minus 1. That means total it will be I elements, right? So total previous elements minus the count of good pairs. So if we find out the number of elements, for example we were at I, we find out on the left number of elements equals to vec of I. Like, so if we find out the number of elements on the left equals to vec of I, then we will be able to find out the number of bad pairs. So total previous elements minus count of previous elements equals to vec of I. And that would be simply I minus the frequency of val of I, which is val of I is nums of I minus I. So we just need to find this value using a rendering algorithm, and we will be able to do this. Means for this frequency, we can maybe create an unordered map so that we are able to access the frequencies in constant time. So it will be of the order of big of 1. So total complexity would be n into 1, right? So this is what we'll do in this problem. Let's see the code. Like, I hope you get the logic. The main logic is to rearrange the given formulae so that we only need to deal with a single index only, and then modify that to like make the problem simpler. So let's see the um, optimized code. So here we'll just create a map to store the frequencies. Now this long will denote the overall result. Now current difference is nums of I minus I. We were at current I. Now the number of elements on left was total I, because 0 to I minus 1 equals to I elements, right? And the number of good pairs would be the frequency of the value present at this value. So it would be MP of nums of I minus I, the overall frequency of elements which we have encountered so far. So diff was nums of I minus I. So good pairs are MP of diff. Hence the bad pairs will be the remaining elements, like the total previous elements minus the frequency of good elements. And now as we move forward, we will like increase the frequency of this element, so that for newer i's this value means the frequency of this value is increased in the map. So we'll keep doing this and we will finally return the bad pairs. So as we can see, like this is of the order of big of n, which is acceptable given the constraints, where the constraints were of the order of 25. So I hope you like now know how to approach these kind of problems where we are given a means where we are given a certain formulas. So you can also try like similar problems. You can go to the similar question section and then try out similar value. Like for example, here it is count nice pairs in array. So here also this formula is given, right? Nums of I plus reverse of nums. So if we somehow like, what is the intuition, we put I and I together. So what we'll do here is nums of I minus rev of nums of I and nums of j minus rev of nums of j, and then we'll find out easily, we'll be able to find out the pairs using some pre-computation. So this is what we do in these kind of questions. Let's try to submit the code once and see how well it runs. Yeah, so like it runs absolutely good. So yeah, I hope like you get the logic, and if you have any doubts, feel free to comment down. And yeah, thank you for watching.